When I first saw the iPhone in person, what really stood out to me was the camera plateau and the surface quality. At the same time, I have noticed again and again that many models rely on simple fillets to create these transitions. While fillets are fast, they often produce harsh highlights, which is not ideal for premium consumer products. That's exactly why I'm making this tutorial. In this video, I'll show you how to model an iPhone or any smartphone in Rhino, and more importantly, how to resolve highlight issues caused by simple G1 fillets using a cleaner Class A approach. Alright, so let's get started. I will make a top reference image and a side reference image to create the drawings. I'll go to the top viewport and let's start to draw the curves. I'll use the polyline command and I will start to make the reference curves. So I'm making these boundary curves for the fillet part, the camera plateau, the wireless charging part. Okay, I'm also making the centroid for the camera modules, the microphone cutout, and the camera sensor, and the flashlight of the camera. I'm also adding gaps to create the buttons. I'm also defining the overall dimensions, so it's a rounded rectangle. And I'm using the same rounded rectangle and positioning it correctly to define the volume up and down and action buttons. So these are the gaps between the curves and the dimensions of the curves if you want to make it from scratch. I'm adding some additional dimensions. I'm also adding the additional cutouts for the antenna bands, assigning them to different layers, and I'm making a separate copy of it so that now we can define the rounded fillets. Now let's talk about fillets. G1 fillets are tangentially continuous, but they often create undesirable highlights. And the reason is simple. The radius of curvature of surface A is not the same as the radius of curvature of surface B at the junction point. This sudden change in curvature is what causes visible reflections to break. Instead of accepting that, we will see how to mimic a simple fillet using a BlendCrv, allowing us to control how curvature ramps up and dissolves across the transition. So to apply the fillets, we will use some reference radiuses. I will annotate it in a moment, and we will define the radius for the camera part, the transition part, and the outer boundary. We will also create an offset curve so that we have a flat section between the two transitions. I will do the same thing for the other wireless charging part. I'm making a copy of it and I'm trimming the access bits because we just want a symmetrical part, and we will just mirror the remaining curves after we have fixed these G1 boundaries. So to fix this G1 curvature problem, what we will do is recreate this curve using BlendCrv command. Now, before we do that, we need a bit of a runway between where the curve ends and where the fillet starts, because we cannot add directly the curvature from the junction point. This is because we need a bit of runway where we go from flat curved section to this curved section. Now, in order to define how much we should recede back from the original boundary, what I will do is measure the radius of these circles using the circle command, and I will scale with the shift key 0.25 of the original circle, and I'm changing the radius of this original circle to 25%. Okay, so once I have that, I will copy it from here to this point and this point, and similarly I will do the same steps for the remaining circles. Now, once we have these curves, we will get rid of the excess parts that you see here. So these are our final set of curves, and now we need to blend the two curves together using these curves as a reference. Now let's see how we can blend these Now, the higher you go in terms of continuity, the better results you will get. But at the same time, there is a mathematical limit of what we can manufacture. So curvature or G3 is a good sweet spot. In this case, we will use a G3 continuity between the two curves. To further understand the continuity of the curvature, turn on Show Curvature command and change the curvature graph parameters. Now you can see how the line gradually curves inwards, and the spikes that you see here, that is defining how much the curve's radius is on the opposite side. So what you can do is press Shift and click on this point and then slowly move it behind or ahead. Now this is gonna proportionately move the 4 points. It's also gonna move these points symmetrically. So this way I'm able to mimic the fillet amount quite precisely that we had in terms of G1 fillet. You can further fine-tune the additional points, but don't forget to press Shift and click. Shift and click, and you can fine-tune this point even furthermore. Remember, we always want to keep a positive curvature here. So try to keep the center spike the highest, and you can take your time to further fine-tune it. Okay, now this looks about right, and I will repeat the same process on the other curves. So once this is done, let's go to the next step. So once we have the blend curves, let me just create mirror copies of these blend curves and connect the intermediate lines. I'm also going to assign a color to all the blend parts so it's easy for us to visualize. And finally, we will create a mirror copy of these curves, and that is the final result of all these steps. Now we have all the curves that we need to make the solid model. So let me zoom into this section, and we are going to extrude this model using the circular handle in the gumball. Let's click on it and write -9.75. Now it has extruded the curve as a solid geometry. Okay, you won't be able to see it until you go to the shaded mode in Rhino. Apart from that, I will select this curve and lift it up in the Z direction. Now to see how much you have to lift it up by, go to the right viewport and use the reference image and lift it up by 2.65 units. Now we will use these curves to create the camera plateau. Now once we have the solid body, now let's make the camera plateau. For that, we just need these two curves. Okay, this is used as a buffer between the fillet and the camera plateau blend. So I'm going to use these two curves. After that, let's explode it. And we only have to work with 1/4 of the curves, because then we can mirror it on this side and then we can mirror it on the opposite side. So this reduces the amount of work that we need to do. Let me isolate it by moving it 100 units. And I will also assign a different color to these blend curves. Now let's create the blend between these two curves. Now I want to maintain position, tangency, and curvature continuity with the bottom surface. Okay, and on the top side we need position, but let me also add a line in the z-axis so that we can blend between these two curves. So here we need position, but let's see if we can get a better result by making a tangentially continuous curve between these two curves. So let's run the command BlendCrv, blend this curve to that curve. We are aiming for position, tangency, and on the edge 2, curvature. To properly understand the shape, let's go to the right viewport, and here you can see the blend curve. Now we just have to click on these points and modify it as per requirement. I'm moving these points, and once it's done, you can press OK. Now we cannot modify this 3 points because we want curvature continuity on the bottom edge, but here we just need position, so I can use this point and position it as per requirement. So I'll nudge it slightly on the right hand side. You can move these points As long as you're moving them left and right, it doesn't matter. The only thing you cannot do is move them up and down. We will lose the continuity. So once the points are calibrated, now let's convert these curves into surfaces. Once I have the curve, I will also mirror it on the other side. So you can Control C, Control V, and rotate it 90 degrees, and then position it on the other end. Let's start by drawing a line between the end of this curve fragment and this curve fragment, okay, which is basically where the blend starts. Similarly on the other side, here to here. Now we will extrude this part a bit beyond where we have drawn the line. We now have to trim the excess part. Same thing on the opposite side. And now let's split these two surfaces using these two curves and get rid of the excess chunks. Let me also delete the lines. Now, one of the problems of this approach is that once you trim a surface edge, that edge becomes a bit more complicated. Let me show you by duplicating the edge. So you can see this edge gets rebuilt with a lot more control points. So if you make anything in that edge, it will share a similar complexity. So in order to resolve this, we will be using a command that you can find in Surface Tools. It's called refit trimmed surface edge. And what it does is it rebuilds the trimmed edge using the original boundary. So let me click here, press enter. Let me click here, press enter. And now if I show you the edge, you can see it's as if it was not trimmed. Okay, so now if I make any surface here, it will share a similar simple complexity of the edge. So let's create a surface. Go to Surface Tools, Surface from 4 edges, edge 1, 2, 3, 4. So this is a simple surface that shares a similar property. Now if I show you the end result in EMAP, you can see there are some sharp corners. Okay, I can also show you in Zebra. The continuity is breaking on these two corners. Okay, so we just need to match this surface to this surface. So let's run match surface command, which you can also find here in Surface Tools, and match surface, match the left edge to the right edge. We are aiming for curvature, and you can see it has fixed the problem. Similarly, this edge to this edge, curvature. So this creates a high quality single span surfaces, and the continuity between these edges is curvature continuity. Now we just need to mirror these surfaces on the other side and then on the symmetry side. You can join them together. And now let's see how to incorporate it in the camera module. Let me move it by 200 units. Let me move it by 100 units. I will split the solid geometry using this part. This is going to get rid of this small fraction of surface. We can now join everything together. And as this is a planar edge now, we can run the cap command, which is then going to fix this into a solid model. You can also check the quality by running emap command. We have a high quality surface model. If you're enjoying this surfacing approach so far, we have designed a Rhinoceros masterclass that dives much deeper into these concepts. In this course, we cover NURBS, curves and surface topology, spans and control point structures, continuity issues like G0, G1, G2, and even G3, and a complete Class A modeling workflow. If you want to seriously improve your surface quality in Rhino, check out our Rhinoceros masterclass. You will find the link in description. All right, so now let's look at the camera module itself, let me zoom into this section. You will see I have added a couple of curves that we can use to revolve and make the camera shape. So let me select curve A, B and C, run the revolve command, select the axis from here till here, and we can create the camera module starting from this part and till this part. Okay, you can also click on this button called full circle and it will make the revolve profile as a solid geometry. Lastly, I will move these camera modules to these points as well. So let me select them 1, 2 and 3, and I will run the copy command. We will copy it from the point that we had at the base, and then we will copy it to this point and that point. Once we have these geometries, let me select them all. We can also group them and move them by around 1200 units. So we have the camera module. Now we need to make sure the height of the module is correct. So let me move it up by 2.65 units. We can also hide all the ISO curves of the geometry. Now let's add the wireless charging part. I'll move the curves here and I will extrude it symmetrically by pressing the shift key. So if I press shift and drag, it creates symmetrical extrusion. In this case, let's press shift and click and extrude it by 1 millimeter. This is going to make a symmetrical extrusion. Let's use Boolean difference to remove the material from the base solid using this. So this creates the cutout shape. And now I will use the boundary curve and extrude it by 1 millimeter. So this is gonna be our wireless charging panel. Let me move it up slightly, let's say 5 millimeters, and I will apply fillet to this boundary. So let's go to solid tools. We can apply G1 fillet or G2 blend by right clicking. So let's create G2 blend, 0.1 millimeter, click and double click to chain the edges. And now we have applied a micro fillet to that edge. Similarly, click and double click and micro fillet to this edge. Let me move it back by -5 and 1 more millimeter, so -6 millimeters in total. You can also look at the end results in the rendered mode or EMAP mode. Let me move these curves and let's run EMAP. So this is how it's going to look like with the micro fillet. Make sure to hide the ISO curves. And finally, we will apply a blend to these boundaries as well. Solid tools, right click blend edge, and we will use a blend of 2 millimeters. Click, double click to chain the edges. Click, double click to chain the edges. And lastly, we need to add the perforations for the mic and the sensors. So I will go back to the drawing and I will copy these 3 curves onto the model. It's around 1600 or 1700 millimeters. Let me move it up by 2.65 millimeters to put it on the surface. And similar to the last time, I will extrude it by pressing the shift key to create a symmetrical extrusion. In this case, we will extrude it by 2 millimeters. For the mic hole, we just need to perform Boolean difference. And for the camera and the flesh bump, we just have to perform Boolean difference or Boolean split. Using the curves, I can also create these geometries like the way we did it for the wireless part. We then have to apply a micro fillet to these edges, 0.1. Let me set it apart by 5 millimeters. Let me apply the fillet again here and position it back. So -5 and -2. Similar to the last time, let's check it in EMAP. And this is the final result. Let me get rid of the curves. apply a micro fillet here as well. That is the end result. Once we have the solids, now let's add the buttons. So if you zoom into this drawing section, I have made the 2D drawing of the curves. And in the next step, I have also oriented the button curves from the right viewport as per the drawing. So let's copy these curves to our model by moving it approximately 2300 units. I have also made a small offset of these curves internally by 0.1 millimeter. So I will use the red curves to cut out the shape and the black curves to create the buttons. So let's see how to create the cutout shape. First, let's select the red curve, and we can either extrude it and perform Boolean difference, or I can use the handle, the line handle, to create the cutout shape. So let's see how can we cut it. Let's select the red curve and move it by -5 plus -2, so -7 units. We can click here and write -7. Similarly on the other side, select the red curves, 7 units in this case. Now let's see how can we add the buttons. So let's select the internal curves, and we will extrude them by 2 + 1 3 millimeters. And position them back to the same place. So I will have to move it by approximately 4 millimeters. I will do the same thing on the opposite side. Let's extrude these internal curves by 3 millimeters, -3 in this case, and move them to the same place by -4. Now let's apply a micro blend, 0.2 millimeters on all of these edges. Similarly on the other side. And that is the final output. Let me show you an EMAP. And this is the final result. We also need to add the cutout for the speaker and the USBC. So you will find these curves here. Let's move them all the way till this part, which is 2500 millimeter. And we will extrude them or use the cutout shape to create the cutout on the model. So in this case, I will extrude them by 5 + 2, 7 units. Okay, and we can add further details to the bottom section. So this is going to be the final output. Now the last step is to create the screen cutout, and I have extruded it a bit longer than where it's supposed to be. So if you look at it from the right viewport, you can see that it's approximately 1 millimeter longer. So we will split the part here. So I will do that by making a surface. And just make sure that the surface starts at any of the edges at the very bottom surface. And we need to make sure that this surface completely cuts out this geometry. Okay, like this. Now I will move it up by 1 millimeter. And this way I can split the geometry into 2 pieces. So let's run Boolean split, object to split, object to split width. And now you can see I have the separate part which we need to delete. After that, we have to add a micro fillet, similarly 0.2 millimeters. And then I need to create a cutout for the screen. So for that, you just need to duplicate the edge, double click to chain the edges, join the curves. Okay, so this is the curve. Now we will offset the curve inside by 1 millimeter. And using this curve, we will extrude symmetrically 1 millimeter and perform Boolean difference to cut out the screen hole. You can see. And using the same curve, we will extrude it by 1 millimeter to create the screen. Let me just separate it away to easily add the blend on this edge. So like before, micro blend of 0.2 millimeters. Let me position it back and hide all the ISO curves. So if I show you the end results in EMAP, you can see we have all the micro fillets, all the buttons, and also the screen at the top. Let me delete the curves. And that is the final output. We can also add a micro fillet here of 0.2 millimeters. And there we go. All right, so this is our final model. Let's go to the rendered mode, and I have applied materials to the model, and you can see it looks pretty good. You can see it looks pretty good. You can see the quality of the fillets in these sections. I hope you learned something new about Rhino surface modeling and Class A workflows from this tutorial. If you like this video format, let me know in the comments below. It really helps. Thanks for watching, and I'll see you in the next one. Have a catful day. Bye.